So in these problems, we are going to have to use an identity to be able to get the problem into something where we can factor or do something else with it. So for example, solve in the interval 0 to 2 pi. And because we're going to need it, we might as well put our picture. Okay. So the first one here is going to be 2 sine squared x plus cosine x equals 1. So if you look at this problem, it has a sine in it, it has a cosine in it. I can't really solve it because I can't factor anything out the way that it is. So what I'm going to end up doing is I'm going to end up using the Pythagorean identity. So if you remember the Pythagorean identity, it says sine squared x plus cosine squared x equals 1. And so I could solve this for sine squared x. And if I did that, that means that sine squared x is going to be 1 minus cosine squared x. So I can replace the sine squared x by 1 minus cosine squared x plus a cosine x equals 1. And now if I distribute that 2, I end up with 2 minus 2 cosine squared x plus cosine x equals 1. And so now I'm at a point where I could bring everything to one side and then be able to factor it. I'm actually going to bring everything over to the right-hand side because it's easier for me to factor if the cosine squared term is positive. So if we subtract everything to the other side, we're going to have 0 is equal to 1 minus 2 plus 2 cosine squared x minus cosine x. So really 0 is equal to 2 cosine squared x minus cosine x minus 1. And now what I want to do is I want to factor that. So this is going to factor into 2 cosine x minus, plus 1 times cosine x minus 1. And remember, you can use my trick if you want to. You can think of this as 2y squared minus y minus 1. And so again, that factors into 2y plus 1 times 2y, oops, not 2y, times y minus 1. And then we're going to set each piece equal to 0. So 2 cosine x plus 1 equals 0, and cosine x minus 1 equals 0. So 2 cosine x equals negative 1, divide both sides by 2. The cosine of x equals minus 1/2. Here we're looking for where the cosine of x is equal to 1. And so all we have to do is pull off these values. So the cosine of x is going to be equal to minus 1/2 when x is equal to 2 pi over 3. And also when x is equal to 4 pi over 3. And the cosine of x is going to be equal to 1 when x is equal to 0. And so we're going to pick 0 rather than 2 pi because the 2 pi is not included in our interval. We're going up to 2 pi, but we're not including it. So we'll do another one of these. Let me put that unit circle back in here. Okay, so now part B, if I want to do the tangent squared x plus 3 secant x equals minus 3. So again, I have tangents, I have secants, they're not the same, so I want to convert everything to be the same thing. And so since I have that tangent squared, I can use the Pythagorean identity again. So remember, one form of the Pythagorean identity is that sine squared x plus cosine squared x equals 1. But there are 2 other forms. So there's that tangent squared x plus 1 equals secant squared x, or that cotangent squared x plus 1 equals cosecant squared x. So if I use that middle one, tangent squared x is going to be the same as secant squared x minus 1. plus 3 secant x equals minus 3. So if I bring everything over to the left-hand side, so we move that minus 3 over, we have secant squared x minus 1 plus 3 secant x plus 3 equals 0. Or secant squared x plus 3 secant x plus 2 equals 0. And again, I can use my trick, so I'm trying to factor y squared plus 3, y plus 2 equals 0, or y plus 1 times y plus 2 equals 0, which means my trig equation factors into secant x plus 1 times secant x plus 2 being equal to 0. So secant x plus 1 equals 0, or secant x plus 2 equals 0. So secant x is equal to negative 1, or the secant of x is equal to negative 2. And remember, secant is the flipping over of cosine. So this is the same as saying that cosine of x is equal to minus 1 over 1, which is still just minus 1. Or cosine of x is equal to minus 1/2. So the cosine of x is going to be equal to minus 1 when x is equal to pi. And the cosine of x is going to be equal to minus 1/2 when x is equal to 2 pi over 3 and 4 pi over 3. So our final answers are x equals pi, 2 pi over 3, and 4 pi over 3. So it's not too bad. You just have to use that identity to first switch it so that you have all the same trig function before you go about the rest of the problem.